video, we will see about what is planning and how it differs from problem solving. So here in this slide, I have given the definition for formal definition of what is planning and where this planning can be applied. So earlier we might have seen problems, mostly searching techniques. In all the searching techniques, either it may be informed search or uninformed search. We will be using. We will not be aware of the environments where we are acting, where the agents are actually acting. So, but any whatever the environment may be, the searching problem searching can be done efficiently. That depends on the algorithm what we are using. But the planning can be applied only to the environments which is fully observable. Either it may be fully observable or deterministics or finite or static and or a discrete environment only. These kind of environments only is suitable for applying the planning techniques. So the formal definition for planning is the task of coming up with the sequence of actions. So generally we will tell what if we ask any if we ask the term what is plan means or what is planning means, we will be telling what are all the actions we are going to perform. That only we will say it as planning. So that is the normal definition. So sequence of actions that will achieve a goal is called planning. It is suitable, which is planning is suitable only for the environments that are fully observable, deterministic environment, finite environment, or static environment on a discrete environment. So these kind of only in these kind of environments only we can apply planning. Okay, so these are called classical planning environments, and these are the things which we are going to observe in the topic planning. So language of planning problems, expressiveness and extensions, and some simple problems, real world problems on planning we will be seeing. Here we will be going through about air cargo transport and spare tire problem, block world problem. Okay, so here is the language of planning problem. So the most classical language for planning is, we call it as strips language. So strips, this is even though so many languages, adaptive languages has been evolved now, but the first and the classical planner method we will call it as strips language. Strips planning language or strips method of representing the informations. So here it consists of, as of normal problem solving approaches, the problem formulation will be having the language to represent the planning. They are representation of states, representation of goals, and representation of actions. So and if normally in problems search we might have seen initial states, goal state, path cost, and actions. So here also it includes the same things. So states, start state, goal state, and actions to be performed. So these are the things which is being normally included, we will be using to represent any kind of languages including strips. So that is what it is given here. Here states represents the actual problem representation state, actual states of that particular problem, we call it as states, and the goal state represents the final goal or final destination where we want to, what we want to actually prove, and the action includes all the conditions which are required to solve that particular um, to execute that particular plan. So that will be represented as actions. And apart from that, we will be having another one called action schema. So action schema includes three major components that is being defined in the above statement. They are actions, preconditions, and effect. So here they have given one example called action of fly off p comma from comma to, which means we are going to fly is an action, p is a plane, and from is the from place, and to represents to place. So the plane is going to fly from place to place. So that is what it is being the action going to be performed. And then precondition represents if I want to apply that particular action, what are all the necessary requirements I need, that should be defined in the preconditions. So if I want to fly from one place to another place, then I have to be currently present at that current place. So that's what it is given as at of p comma from. If a plane wants to fly from place to place, a plane has to be present in the from place, and there should be a plane called p. So plane should be available. So conjunction and plane of p, and airport is from airport, because from airport place to airport place we are going to fly. So from airport and to airport. So in this is the precondition for applying the above action. If these all these conditions are satisfied only, then I can go with the action which is given as fly of p comma from comma to. Then if I perform that action, what will be the effect? The plane won't be present in the from place, which means it will be present in the to place. So negation, a plane negation at from, and p should be present at to airport. So negation p at from and p at to. So this is the simple example of action schema. Action schema includes action, precondition, and effect. So that is what it is given in the upcoming slides. The action schema consists of three parts. First one is action, which includes what action we are going to perform. And the second thing, it includes preconditions, which means the conditions that is required to perform the particular action. So that is precondition. And then third one is effect. After applying the particular action in the certain precondition, what will be the output or what will be the effect? So that is given here. So action schema generally consists of these three components. So here we can say in order to improve the better readability, or as we have already seen, right, expressiveness, or in order to make the planning more effective, apart from the components listed in the action schema, we can also include additional things like add list and delete list in the planning problem. Okay, so that is what it is given in this slide. To improve readability, some planning systems divide the effect is further divided into add list and delete list. So here you can see the difference which is being given between Strips language and ADL. So ADL is the language that is developed after Strips. So what are the major differences they have given in this table? I will tell one by one. So the first point is in Strips language only positive literals are allowed, whereas in ADL language, abstract descriptive language. So ADL stands for abstract descriptive language. So it allows both positive and negative literals. So the example they have given here, poor and unknown, here not rich and not famous, which is more, both are same. So negative literals are allowed in ADL languages, whereas positive Strips supports only positive literals. And then second point is Strips language allows closed world assumptions, which means closed world assumption represents if we don't specify any literals or values to that particular literals, it will by default it will take it as a false. So that is closed world assumptions. Whereas open world assumption means if any literals is missing, or if any literals is not known, it will be kept as not unknown only. So that is what it is given. And this is a major difference between Strips and another difference between Strips and ADL language. And then next one is effect. So P and negation of Q means it adds only P and delete Q. So negation of Q will be added. Whereas P and negation Q, which means here it adds P and delete negation P, and it adds negation Q and deletes Q. So once if you go through again slowly, then you will try to understand the difference. And then next point is only ground literals is allowed here. Here, quantified variables are also allowed here. As of like existential quantifier, universal quantifier is also supported in ADL languages. Whereas only the basic literals are being supported in Strips languages. So, and then it is all combination of conjunctions only, but here it includes conjunction and also if then effect is also included here. Then here equality in Strips language, equality is not supported, whereas in ADL language, equality operation is supported. So these are the major differences between Strips language and ADL languages. And then next comes the expressiveness. So here they have given the other languages which are developed after Strips. They are ADL, action description language, and then PDDL, which is planning domain definition language. So these are the two languages that are developed with more expressiveness when compared to the Strips language. So here PDDL also includes hierarchical task networks, we can see, in which the problem is divided into so many subdivisions and it will be sub problems and it will be solved again. So this is being included in both the languages, which is ADL and PDDL, are improved, enhanced and with enhanced and improved and is being produced in the these when compared to Strips language, it is with more expressiveness and extensions. So here is an example, our first example, air cargo transport. Here the problem is that we are transferring the cargo and cargo, we are loading the cargo into the airplane, and then we are transferring the airplane from one airport to another airport. That is what stated in this particular problem, a simple problem that is helps us to do the planning. So for that only they have given the simple example, and the possible actions are load, unload, and fly. So load means we will be loading the cargo into the flight or plane, and then unloading means after reaching the another airport, the cargo has to be unloaded from the plane, and after loading the cargo into the plane, it has to fly from one airport to another airport. So that's why we have given three different actions: load, unload, and fly. So here the task is given, and this can be represented with the given solution, which is we are representing the two cargoes as C1 and C2, and the two planes are represented as P1 and P2, and SFO is San Francisco some airport name, and JFK is John F. Kennedy Airport. So this is SFO and JFK. We are going to transfer the plane 1, which contains cargo 1, from SFO to JFK, and also plane 2 is available in SFO, and we are going to make it fly to SFO. So this is the task, and here is a simple Strips planning method that is being given with the initial state. What is the initial state given here? Initially the cargo is at SFO and the plane is at SFO. Plane P1 is at SFO and cargo C1 is at SFO, and plane 2 is at JFK and cargo 2 is at JFK, and the cargo 1 and cargo C1 represents cargo 1 and C2 represents cargo 2, and P1 represents plane 1 and P2 represents plane 2. Both the planes are available at the airport JFK and SFO. So that is the initial states given. And what is the goal state? Cargo 1 has to be sent to which is currently available in SFO, that has to be sent to JFK, and cargo 2 which is available in JFK, that has to be sent to SFO. So that is the goal state given. So for achieving that goal, what are all the actions need to be performed means one load operation, one unload operation, and then a fly operation. So for this is a general scenario I have given, but for C1, cargo 1 and plane 1, it has to be these three actions to be performed separately, and for cargo 2 and plane 2, Again, these three actions has to be performed separately. On performing these actions, we will be trying to achieve the goal, which is given as C1 at JFK and C2 at SFO. That has to be obtained. So that is the simple problem. And next example is spare tire problem. So spare tire problem is similar to that of one which we have already seen, which is air cargo transport. Here, spare tire problem consists of a spare tire will be available in the vehicle, which is car, and a flat tire will car's tire is already flat, which means the spare tire has to be replaced in the axle on the flat tire. So that is here the four actions includes removing of spare tires and removing of fat tire from the axle, and then putting the spare on the axle and leaving the car overnight, unattended overnight. So these are the four possible actions. So how these can be performed in order to achieve the goal. This is another example they have given. Initial status, tire and the it in the axle should be flat, so that's why it is given as flat at axle, and spare tire should also be available at the trunk of the car. So at the spare comma trunk it is given. What is the goal state? That spare tire from the trunk should be replaced at the axle. So that is the goal state. In order to achieve the goal state, we have to perform the below actions. What are they? We have to remove the spare tire from the trunk, and we have to remove the flat tire from the axle, and we have to put that spare on to the axle and leave the car overnight. So that these are the possible four actions. On performing these four actions, the above goal can be achieved. So this is the another simple planning problem solution using the STRIPS language.